2.4 Inequalities. Rules for graphing inequalities. Use an open circle for less than or greater than sign. Use a closed circle for less than equal to or greater than equal to signs. Let's talk about non-inclusive and inclusive. For symbols, non-inclusive, which means the solution is not included, would be your less than or greater than, and your inclusive symbols would be less than equal to and greater than equal to. Non-inclusive graph, use an open circle. Inclusive graph, use a closed circle. For interval notation, non-inclusive, you will use parentheses, and for inclusive, you will use brackets. Infinity and negative infinity will always have a parenthesis, as you cannot contain infinity. We're going to begin by graphing inequalities on a number line. Here we have x is less than 3. So I will place an open circle at 3. When the variable is first, the arrow appears to point in the same direction as the inequality symbol. This appears to be an arrow pointing to the left, so my graph will also point to the left. I'm going to use this graph to write interval notation. This arrow points to the left, meaning it goes on forever into negative infinity. You cannot contain infinities, so I will begin with a parenthesis, negative infinity, and then our greatest possible value is 3. 3 is not part of the solution, so this interval will end with a parenthesis. In this example, x is greater than negative 1. There is no equal sign, so it will be an open circle on negative 1. And the inequality symbol appears to point to the right, so my graph will continue forever to the right. The least possible value on this graph is negative 1, open circle, so the negative 1 is not included. The interval notation will begin with a parenthesis, negative 1, and then the graph continues on forever into positive infinity. Infinities cannot be contained, so you end with a parenthesis. For number 7, write as an inequality and as interval notation. So in this example, we're looking at 0 and everything less than 0. So x will be less than or equal to, because of the closed circle, 0. So the least possible solution would be negative infinity, parenthesis, up to 0, we're going to close with a bracket. And number 8. Here we have negative 3, and we have an open circle, and anything greater than negative 3. So x is greater than negative 3. The least value on the graph would be negative 3, parenthesis, to positive infinity, close with a parenthesis. Rules for solving inequalities. To solve an inequality, you will use the same steps as in solving equations, with one major difference. You must flip the inequality symbol when you multiply or divide by a negative number. So let's do number 9. The first thing we need to do is subtract 2 from both sides, leaving us with 3x is less than negative 6. Divide by 3, divide by 3. X is less than negative 2. It doesn't matter that your answer is a negative. What matters is we did not multiply or divide by a negative number, which is why the inequality symbol did not flip. Graph, and write the interval notation. This graph goes from negative infinity to negative 2, end with a parenthesis. Pause the video and attempt number 10. Subtract 2 from both sides. X over 6 is greater than negative 3. We're dividing by 6, so we need to multiply by 6 on both sides. 6 is canceled, leaving us with x greater than negative 18. Graph. The least possible value for our interval notation would be negative 18, non-inclusive, begin with a parenthesis, negative 18 to positive infinity, end with parenthesis. Number 19. First, we need to subtract 4 from both sides, giving us negative 1/3 x is greater than or equal to 7. We need to multiply by negative 3 both sides. Negative 3 times negative 1/3 cancels, leaving us with just x. Because I multiply by negative 3, I need to flip the sign. Negative 3 times 7 is negative 21. Graph. The least possible value is negative infinity with a parenthesis. To negative 21 ends with a bracket. Number 20. Long division bar means I need to get rid of the negative 2 first. Opposite of dividing by negative 2 would be to multiply by negative 2. Both sides. Negative 2's cancel, leaving x plus 11. Flip the sign because we multiply by a negative. Positive 4. Subtract 11 both sides, leaving us with x is greater than or equal to negative 7. Graph. Least possible value is negative 7, inclusive, so bracket, to positive infinity, parentheses. Amber is selling knitted scarves and beaded jewelry to make some extra money. The scarves cost 90 cents to make. She has already spent $16.05 in jewelry supplies. If she spends a total of $25.95 on all supplies, will she be able to knit at least 4 scarves? So she will be spending 0.9 for each scarf plus the $16.05 she's already spent on jewelry. That must be less than or equal to the amount she has to spend, $25.95. Subtract 1605 both sides. 0.9x is less than or equal to 9.9. Divide by 0.9. Divide by 0.9. X is less than or equal to 11. So the fewest number of scarves she can knit is 0, inclusive, and the greatest number of scarves she can knit is 11, inclusive. Amber will be able to knit up to 11 scarves. Pause the video and attempt 11, 12, 17, and 18. Tony can carry up to 14 pounds in her backpack. Her lunch weighs 0.85 pounds, her gym clothes weigh 2.4 pounds, and her books weigh 2.9 pounds each. Write and solve an inequality to determine the maximum number of books she can carry in her backpack. 2.9 times the number of books plus 0.85 for her lunch plus 2.4 for her gym clothes. That amount must be less than or equal to her backpack's weight limit of 14 pounds. Combine like terms. 2.9b plus 3.29 is less than or equal to 14. Subtract 3.29 from both sides. 2.9b is less than or equal to 10.71. Divide by 2.9. Divide by 2.9. b is less than or equal to 3.7. She can carry as few as 0 books up to 3 books. She will not be able to carry more than 3 books as it would exceed her backpack's weight limit. Tony can carry up to 3 books.